Hi everybody, in this video we are talking through task 12.7 and we are looking at finding the slope of a segment, the distance between 2 points, and the midpoint between 2 points on a coordinate plane. Alright, so this is on page 49 in your packet. Go ahead and flip there if you're not with me already. And then let's go ahead and jump in here. So a lot of this is going to be a review of things that you already know, but it's going to be useful for task 12.8 that we're using next. All right, the slope of a line, remember that tells us the steepness of a line. So when we're looking at a graph, we always think of this as the rise over the run. So we just pick a point to start. In this next example, I'll start with the one on the left here. So I go up first, we go up by 4, and then we do our run. So run over here to the right by 4. So our rise over run is 4 for our rise, 4 for our run. We always want to simplify this so we get 1 for our slope. Oops. Alright, we want to take a look at the next point here, or next example here. So again, looking between these 2 points, I'll start with the one on the right. We go down by 3, so I'll always put a negative in front if we're going down, just to remind me not to forget it when we put that in our slope. So don't forget that negative there. And then we're going over to the right by 6. Also, if we go to the left, it's going to be -2. So we go down the elevator, then step off onto the floor. Okay, so always go up or down before you move left or right. So our slope is going to be -3 divided by 6, which simplifies to -1/2. Right? Always simplify your slope again so you can see what it's equivalent to. The next section we're going to look at is finding the distance between 2 points. So there's a couple different ways to do this, but we are going to talk about using Pythagorean theorem for this. So remember, with Pythagorean theorem, the first thing we need is a right triangle. So I'll make a rough sketch of one. Ooh, that's a little bit off. So a rough sketch of one there. We need a right triangle, and then we have our sides are going to be a leg, and then another leg. Those two are the ones that are touching that right angle. Then across from that right angle is your hypotenuse. So our Pythagorean theorem is our leg squared plus our second leg squared equal to our hypotenuse squared as well. Right, we could also give these legs and the hypotenuse names. So if we call the blue A, the pink B, and then our hypotenuse C, you've probably also seen A squared plus B squared equals C squared. Alright, so we are going to use this for finding the distance between 2 points. So let's take a look at our first example here. The distance I want to find is just exactly what connects those 2 points. And then we are going to create a right triangle here. So I'm going to drop down my Y to find my horizontal leg. And then I'm going to go across with my X to find my vertical, or I just switched that. So the blue is our oh my gosh, one more time. The blue is our vertical leg, the pink is our horizontal leg. So the blue is 4, horizontal is also 4. So when we're setting up Pythagorean theorem, we'll just call our distance here D. So 4 squared plus 4 squared equals D squared. Alright, simplifying this, we'll get 16 plus 16 equals D squared. So 32 equals D squared. To undo that square, we're going to take the square root of both sides. So that gives us about 5.7 is equal to D. So go ahead, you can always plug that square root into your calculator. We're going to round it to the nearest tenth. Last thing we're going to look at is this example to the right. Why don't you go ahead and pause the video and see if you can find the distance here between those 2 points. Alright, so hopefully you took a look at that. Again, we want to drop our Y down, go across with our X to find our legs. So we'll get 3 and 6. So when we set up Pythagorean theorem, we'll have 3 squared plus 6 squared equals D squared. So 3 squared is 9, plus 6 squared is 36, all equal to d squared. Simplifying that, we'll have 45 equals d squared. Take the square root of both sides there, and we should get that it's about 6.7 after we round is approximately equal to d. So that is how we find the distance between those 2 points. Again, there's a couple different ways we can do this, but we'll use Pythagorean theorem because it'll help us later too. Right, let's go ahead and take a look at finding the midpoint between points. So before we've talked about how to find the midpoint of a segment. Now we're going to look at when this is on a coordinate plane, how that changes a little bit. So if we want to find the coordinates of the midpoint here, then what I do is I use kind of finding, I'm going to look at what's halfway between these 2 points here, right? So halfway between them, if this length here is 4, I'm going to do 4 divided by 2 gives me 2. So I'll go 2 from the left, 2 from the right. That gives me my midpoint. I'll change my color here. That gives me my midpoint right here at 4, 4. Right, again, we want to find the midpoint between these 2 points now. The length of that segment is 3, so I can do 3 divided by 2 gives me 1.5. So going up by 1.5 from the bottom, down by 1.5 from the top, that puts my midpoint here at 4, 3.5. Right, so we went up by 1.5 on each side there. Right, so we looked at kind of that horizontal and vertical segments, so it was easy to find what that would be, right? We had enough boxes to count and everything. But let's go ahead and try to find it when it's a diagonal segment. So that's a little bit different. So go ahead and pause the video, try to find the coordinates of the midpoint in this line segment here. And then I will talk us through some strategies you can use here. So kind of the first one is just thinking about finding what's halfway between both our x and our y. So I'll kind of think of dropping down my x's and y's and finding what's in the middle. So finding halfway between my x's, I'm going from 1 to 5. Halfway between that is going to be 3. So that puts me right here for 3. Let's take a look at our y. So we go from 3 to 7. Halfway between that is going to be 5. So my midpoint is going to be here at 3, 5. Right, so that is one way we can think of this. You might also remember your midpoint formula. For that, we add together our 2 x values and our 2 y values, and then divide by 2. So 1 plus 5 divided by 2 gives us 6 over 2, which is 3. Finding kind of the average between these points, 7 plus 3 divided by 2 will give us 10 over 2. Simplifies to 5. So again, we find our x and y coordinates match with either method of doing this. So kind of describing what these are, our different options, we can use halfway between our x values, comma, halfway between our y values, or we could also look at, again, that midpoint kind of formula to calculate this. So that was our first x value plus your second x value divided by 2. And then our y is our y1 plus y2 divided by 2. So this happens when you have 2 different points. So you have x1, comma y1, and then x2, comma y2. So those are 2 different ways we can think about finding the midpoint. So let's go ahead and use that process we described to find the midpoint of this segment. So go ahead, pause the video, see if you can work through this. Right, hopefully you gave that a try. So my first point here is at 4, or sorry, not 4. I need my x first, so 2, 4. And my second point here is 8, 1. So if I use our calculation here, I can use my 2x values, so 2 plus 8 divided by 2, right? I have x1, x2, and then y1, y2 to find my y coordinate here. So 4 plus 1 divided by 2. Simplifying this, I get 10 over 2, comma, 5 over 2. So for my midpoint, I get 5, comma, 2.5. So finding that here, I go to 5 up to 2.5, which looks about halfway between those. Again, you could also try to find halfway between your x and y's. So our y's will have to go in by 3 each time to get us halfway, and then our x's, we would have to go up by 1.5 to get us to that halfway point. So either way, thinking of this could give you your midpoint there. Right, the last thing we're going to do is kind of throw all of these things together to do some practice with coordinate geometry. Again, this is what we're going to be using in our next section a lot. So first thing we'll do is, given these 2 points, we're going to graph them. So our first point is A, which is at 3, 9 up here. Our second point is, and let me label that for us. So this is A. Our second point, B, is at 7, 2. So let's go ahead and find the slope between these 2 points. So I'm going to connect them just so it's a little bit easier to see our distance once we get there. So first we start with our rise. So I'm going down by 7, I believe. So down by 7, that's going to be -7 for my rise. Whoops. And then our horizontal change here is going to be 4. Now we made our right triangle as well, but let's, before we jump into our distance, we're talking about our slope here. So our slope is -7 over 4, and that won't simplify at all, so this is our slope. Next thing we want to do is find the distance between A and B. So again, our vertical leg is 7, so 7 squared plus 4 squared for our horizontal leg gives us the length of AB squared. So the length of AB again is going to be that distance between the two. So 7 squared is 49 plus 4 squared is 16. This is equal to AB squared. The length of AB squared, sorry. Right, adding those together, that should give you 65 equals the length of AB squared. To find the length of AB by itself, we square root both sides, and when you plug that in your calculator, you should get I'll put the length of AB is equal to 8.1 when we round that to our nearest tenth. Right, last thing we have to do here is find the midpoint of segment AB. Sorry, that should say of segment AB. So then we use our x coordinates. Adding those together, we have 3 plus 7 divided by 2. Adding our y coordinates, we'll have 9 plus 2 divided by 2. So our x coordinate is 10 over 2. That's popping up a lot. 10 over 2, and then 11 over 2 for our y. So simplifying this, our midpoint should be 5, 5.5. I can check that on my graph. That should be just about here. Might look a little bit off from my segment because I didn't draw it too straight, but that is our midpoint here. So we will be doing more practice of this in section 12.8, kind of tying all of these things together to connect them to our properties of parallelograms, or not just parallelograms, to quadrilaterals. So go ahead and try the ready, set, go practice for this, but that is it for this video.